Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about this RFID. RFID means for radio frequency identifications. So instead that we use this in ADC, that is an automated data collection technology. It works for this. It uses this radio frequency wave to transfer data between the reader and a mobile item to identify that particular item. So categorize or track anything to that particular mobile item that will be read from a readers. So it's a fast and it does not require a physical side. That is a line of contact which is not required. So contact between the reader and scanner or a tagged item is not required in this RFID tag. And then it performs the operation using a low cost components. So the components used in this RFID system is very low. So it attempts to provide a unique identification. So and then it will be integrated with the long range of application. This is the main reasons we choose this RFIDs. Look at the RFID components. Look at this. This is an RFID tag. Look at this. This is an RFID antenna, and that will be connected to this RFID reader. So from this RFID reader, that will be connected to the Ethernet network, and then from that network, the data will be connected to the workstation. So once this is a mobile item and this is a fixed. So once the RFID tag is detected within this range, so this will be informed and the data will be updated in the workstations. Look at this RFID tags. So it can be attached to almost everything. So it can be attached with items, cases, or plates, or product, or a high volume of goods, vehicles, assets, livestock, or personals. So many things, everything we can attach this tags. It will be very easy to attach that RFID tags. So we have two types of RFID tags. One is a passive tags and another one is a active tags. So first one, passive tags, it does not require power, no power to be connected to this passive tag. So normally we prefer to use this passive tags. So it will be draws from the integrated fields. So the transmitter gives some power now. So that power will be used for the passive tags. So lower storage capacity, it can store up to only a lower bytes. So up to 1 kilobyte only it will be possible. So it have the only that RFID tag values. So it will be the range also very less. So shorter range. So 4 inch to 15 feet that will be possible of communicating this RF passive tags. Usually write only write once and read many. So normally we can take it as a ROM, read only memory tags will be used here, because there is a no power will be given and there is a no possibility of writing anything, and there is a no possibility of retaining the data present in the RAM. So if you use a RAM, what happens? We need to connect an external power supply to maintain the data. That's why we are not preferred to use any RAMs here. We use only ROMs. So we can program only one time. The data will be present even without power also. So it will be cost around 25 cents to few dollars. So around 100 rupees or less than that will be it comes this. Look at this another method. This is an active tags. So active tags, it will be suitable for a high range of communication, high volume of data storage. We can prefer this active tags. But this is a battery powered. We need to connect a battery for the tag also. So not only reader, the tag also should be connected with the power. So both devices. So normally, so handheld device or a portable devices we use. That's why we prefer to use this passive tags. Sometimes we need to store some more data or we need to communicate for a long range. We can go for this active tags. So all the tags so must be connected with the power also. So reader also connected with the powers. Look at this active tags. So this is a battery powered, high storage capacities. So up to 512 kilobytes where data can be stored. And then the communication range, it will be 300 feet. There it will be supports up to look at this 4 inch to 15 feet. But look at this here, it will be supports up to 300 feet. So typically it can be rewritten with the RF integrators, because we use a battery powered, we use a RAM. So the data can be modified. So both read and write operation will be possible. So cost will be a little higher. So it will be $50 to $250. So the memories, so we use different types of memories. So first type, it is a read only tags. So that means only read operation will be performed. So this ID tag is assigned in the factory manufacturing places only we can write it. So it will be possible of only reading. So the data cannot be changed, that is cannot be changed at any time. So only during manufacturing we can program some values, that value will be an RFID tag values. So no additional data or any changes will be possible. Second type of memory is that is a write once read many. So this is also ROM only, but we have this program ROM. Program ROM means one time it will be programmable and remaining we can only perform read operation. That's why this is a write once read many, WORM. Write once and we can read many times. So data written only once. So during a manufacturing or a during packing or a during customer place. So any one time we can write the data. That's why we normally take it as a PROM, programmable read only memory. So only one time it is a programmable. That program data can be written any number of times. Look at this. This tag is logged once the data is written. Once written, it cannot be modified. So this is a similar to compact disc, CD or a DVD or like that. So these are will be only one time writable. No, similar to this is the WORM. And then third method, read and write tags. So these data can be changed over the time. So whenever we require, we can change the data. So we can modify the data. So these will be read write data. So normally it's like an RAM. Reader function. So reader function is to communicate with the tag and get the information. So remotely power tags and establish a birational data link between the reader and then tag. And then inventory tags filter the results, communicate within the network servers. It can read around 100 to 300 tags per second. Within a second it can read around 100 to 300. And readers, it can be fixed points such as a entrance, exit or a point of sale. So these places we will fix these readers. Whenever they crossing or come near to that data will be detected. So reader can be also movable or a handheld. This is also possible. So we can mobile, that is we can movable or we can take a handheld device also for a reader. So normally if you go for a supermarket or anything, there the reader is fixed. But if you go for some application, we can use this mobile or a movable or a handheld devices for the reader functions. Thank you.